Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, we will see a concept of sector area and arc length. It is a part of the syllabus of secondary mathematics and a part of the syllabus of many examination boards. So let's see here. A sector is given to you with radius radius 6 centimeter and angle 20 degree. And you have to find the area of a sector and arc length of the sector. So you need to recall the formula here. So here is the formula for the area of a sector, theta divided by 360 into pi r square. So you just need to plug in the values here. So your theta is 20 divided by 360 into pi and your radius is 6. So substitute the values in the calculator and you will get 6.28 square centimeter. So the arc length of the sector. So again you will use the formula which is theta over 360 into 2 pi r and substitute the values here. So 20 over 360 into, this is radius, okay, 2 pi and radius is your 6. Now when you solve it, it will be equal to, let me use the calculator, 2.09 centimeter. So you got the area of the sector and a arc length. So this arc length is 2.09 and this whole area is equals to 6.28 because this will be used later. So please remember this, what we are talking about here. Now let's go to the next part of the question. A whole cheesecake is a cylindrical radius. So basically, actually, the cheesecake is in this form. Okay, I'll erase it. I'm just trying to explain it to you. And then part of it is cut. So you have to imagine just like a cylinder and you're cutting this slice out of it. So this is what he's talking about here. Okay, whole cheesecake is actually cylindrical in shape, but this slice is the part of the question, I would say, at the moment. So height of this cheesecake is 5 centimeter. You have to find the volume of a cheesecake. Now, of this slice basically. Now here you need to remember one thing. Remember when we find out the volume of a cylinder. Now this is your cylinder, okay? And what is the formula? Because no formula is given to you in the question. So you have to use here the concept. The volume of a cylinder is pi r square h, where h is the height of the cylinder and pi r square is actually this whole area. So in the case of this slice cake, my area will be this sector and height will be same as the height of the cheesecake. So for part 1, just a minute. When I will find out the volume of the slice of cheese, volume of slice of cheese, I'm just not writing complete statement here. So it will be area of a sector, right? Area of a sector times height. You understand how did I get it? I have just given you the reference why pi r square h is the volume of a cylinder. So similarly, area of a sector we have just calculated in the above part, which was 6.28. So it will be 6.28 times 5. So it is equals to 31.4 cubic centimeter because we are talking about volume here. In part 2, he is talking about the total surface area of the slice of the cheesecake. Now this is also required some understanding. Let's see here. So total surface area of this slice. Okay, now if you look at this slice, this portion is same as on the other side and this is actually a rectangle. So 6 times 5. So I can say 6 times 5 and I am doubling it. Why? Because it is on the both side. Plus this blue area, which is area of a sector, it is in the bottom also here, which is hidden. So you can say 2 times area of a sector, right? Area of a sector, which was 6.28. So 2 times 6.28. Now, after that you will add here this area, side area. Imagine, okay? This side area which is shaded here. Let me see here, which is shaded here. So now here you need to understand one thing. You remember in the cylinder, when you find the surface area, what is the surface area of this curve? It is always equals to what? When we write the surface area of the cylinder, we write 2 pi r square plus 2 pi rh. This 2 pi r square is actually this top thing and the bottom thing. And this side all around it, in the cylinder all surrounding is 2 pi rh, where 2 pi r is the circumference and h is the height. Similarly, I'm repeating it. When we are finding out the curved surface area, because now I have to find out the curved surface area of this slice, right, which is here. So when we find out the curved surface area of the cylinder, all around it is the circumference of the cylinder, which is 2 pi r, and height is the height of the cylinder. In this case, the height of the cheesecake is 5, but the curve is only this much, which is the arc length. Okay, rather than the whole around it, it is only this much part. So which is arc length was 2.09. So 2.09 times 5. You understood how we are finding out the total surface area. So now let me calculate it. It will be equals to 83 square centimeter, right? So you can also calculate yourself in the calculator. So it is coming to 83 square centimeter, the total surface area of the slice of the cheese. Now the last part of the question, the radius r and height h of a cylindrical cheese, I have drawn the diagram here for you, vary. It means h and r are changing, but the volume remain constant. Volume remain constant. Which one of the following statement out of this A, B, C, D is correct? So without even looking at it, the common sense says that the relation between H and R will be inverse. If one is increasing, the other will decrease, only then the volume will remain constant. So let's see here. So let's recall the formula for the volume of a cylinder, which is pi r square h. Okay. So if question is saying h is proportional to r, so part A mean h is proportional to r. Part B mean h is proportional to r square. C means h is inversely proportional to r. And part D mean h is inversely proportional to r square. And because he's saying volume is constant, it means I can write here h is equals to v into r. H is equals to vr square. H is equals to v over r square. H is equals to, r and v over r square. Now which one is correct? If I make h a subject here, v over r square. Pi is a constant, so just leave it behind. So it means this D is right choice. Okay, so your answer for this part will be D. Now part 2. Now this part 2 is also a little tricky here. Part 2 is saying what happens to the height of the cylinder cheese when the volume remain constant but the radius is doubled. So right now this is the scene. Okay, right now it is like this. So if your radius is doubled, so let's see, h becomes h1 and radius become 2r, because radius is becoming double. So we have to see in this situation what it will be. This is h1 and this is 2r square. So now volume is equals to, okay, and one thing, I have to substitute the value of volume here. So volume is what I have here. Volume is equals to hr square. So this question will become, just a minute, h1 volume is hr square over 4r square, right? What I'm doing, let me tell you again, volume is hr square, I have taken it from here. So when question is saying height of the cylinder cheese, what happened to the height when the radius is double? So I have made h the subject and I'm replacing volume by hr square. When r is double, 2r, the height will be h1, I'm taking it. So I plugged in the value and this will give me that the height will be h over 4. So I hope you understood this question, and please share it with your friends. Press like and subscribe button. Thank you very much. Take care. Allah Hafiz.